The truss structure, which was the focus of the last assignment, was a discrete structure. Coordinates or displacements at a finite number of discrete locations, namely the joints, determine the full configuration of the structure. Many structures, however, don't have such a natural discrete representation. So what are some examples of structures that don't have a discrete form? For example, dams, soils and earth structures, shear walls, even if we think of not a frame but individual beams. These are not discrete structures, but these are called continuum structures. So you should think of other examples of discrete structures and continuum structures to understand what the distinction between them is. So in this assignment, the goal is to develop Tonti diagrams for continuum structures. So recall our Tonti diagram from the truss exercise. So if we look at Tonti diagrams for continuum structures, which we will develop by the end of this assignment, there will be two main differences. First, the matrices will be replaced by derivative operators. And second, there will be two additional legs to the Tonti diagram representing boundary conditions. So we'll see what these are as we make progress through the videos for this assignment. So we'll start with a very simple continuum structure, namely an axially loaded non-prismatic bar, as shown in this figure. We see that the left side of the bar is fixed. On the right end of the bar, there is a force being applied, and there is also a distributed axial external force in the axial direction, which is P hat of x. So note that if we want to describe the shape of this bar, we need to know the x position of each point on the bar, which means we need to know the x positions of an infinite number of points, and therefore this bar is a continuum structure.